Okay, so I've got construction outside, but that's okay, we'll figure it out. This is a small quick access safe that I had an issue with recently where one of the buttons was getting very sticky and didn't want to work correctly. So I decided it's either going to be trash or it's going to be fixed. So I started tearing this thing apart, and I thought I'd share exactly how you get this thing in two pieces. So first thing, of course, you want to unlock it and open it. Now, I've already taken this apart, obviously, so I'm just going to show you where everything was. There are two screws that hold this side on, plus these three clips. So the two screws are here, and they're just regular Phillips screws. They look like this. And you take these two out, and you take these two out, then you can start popping out the side. Now these things, I was able to keep this one safe by, you just kind of squeeze the ends of this. Let's see if I can get that there. There you go. Get some more light on this. But you just kind of squeeze the ends of this and you're able to get it out, but it's off in this corner over here, so you need to take off this hydraulic lift thing first. Now you could take it completely off, but I only took the screw out of the bottom of it, so I removed that screw and then this comes straight out. The screw looks like that. It's fairly long. But then you're able to squeeze that out, and also this one you're able to get out from here. Now I have modified mine a little bit. I have this little added circuit that I have a video about, but essentially that guy, whenever it's closed, the power's off. Whenever you open the lid, you see that the lever lifts up and this LED comes on. So it lights up the inside of this pretty well. And after about 30 seconds, this automatically turns back off again. So if I leave the lid of this open, the light turns itself off and it doesn't burn out my battery, because this only has a AAA battery. And I've replaced this once in about 4 years. So they last a pretty good amount of time here. Let's see how much longer this thing has to go. I haven't touched it again. So we'll see when that thing turns off. So there you go. So that guy's turned off now. And however long that took, I wanted approximately 30 seconds. That's what I figured it out to be. And I have a video talking entirely about how that board works. So I'm gonna yank out this battery. Sorry for the construction outside. I can't really control that, and I'm probably not going to redo any takes here. I might just change to a voiceover if it gets too annoying. So I found there are two screws that are holding in pins. So there's a screw here and a screw here that are holding these silver pins in. And whenever you lift up on this guy, you're able to yank these pins out. They just slide out once you have the retainer screws out. But they just slide out just like that. Can be a little challenging to get out there, but that's what those guys look like. I'm just going to slide the other end out there. And now I'm able to take this lid completely off so I can get that out of my way. And you'll need that out of the way in order to take this guy apart. Now, something I did off camera already was I removed the foam out of the bottom of this, because you're going to have to take this foam out to get to this main module here. And I also removed a section of foam here so this can slide out, as otherwise it won't fit out. So now that I have that out, you need to take out the bolts on the bottom. There's a bolt here, and a bolt here. And those are all pretty small. I found they're probably 8mm, but I ended up using 5/16 because I didn't have an 8mm. I only had 7 and 9. So once those are out though, this guy can just slide over to the side. So now that will not slide when you have the lid on, but that will slide once you have the lid off, and then this guy just pops out. So that actually is holding this module in place. Then we're gonna take this entire module and we're gonna slide him out this way. You gotta make sure that it slides out evenly or it won't work very well. And you can see my buttons already fell down and out. But now this is all of the electronics inside of this case. So this guy is gonna go onto my floor now. I'm just gonna set this down there, get him out of the way. And here you can see that the button board is connected by a 3-pin connector here. So I'm going to go ahead and disconnect that 3-pin connector. And additionally, on this little board here, we have a motor connection that's for actually driving the mechanism to lock and unlock. And then we have the battery connection here that goes around through the case there. So I have not removed this portion yet, so let's take a look what's inside of there. It looks to be just 2 screws holding this guy on, so let's take a look. I do still have power applied to this. I probably should take the power off, but that's okay. It's not going to hurt anything. So I got this guy coming out of there. Yep, it appears that that's the locking mechanism that's going to slide like this. It appears that that was just sitting on top of here. And there's our battery box, so that's where the batteries actually sit. I dropped a screw into there a second ago. So of course what I'm interested in is the electronic side of this. Take off the battery connection there so we don't have battery causing me any problems. And I'm going to attempt to remove this board without breaking it. Push here, looks like, and I should be able to pop that board out. There we go, no problems. Let's take a look at this main control board here. Starting in kind of a weird spot on the back of the board, we have this triac in a through-hole package. We know this is a triac from the markings, but also it's labeled as T1, which is a little hard to see in this picture. I believe this is being used as a type of crowbar protection, intended to short out the supply in the event that too large of a voltage is connected, which will blow the fuse you'll see on the other side of the board. That's the only through-hole part on the board except for these 3 connectors that are going to go to the motor, the battery pack, and the button board that we'll get to in a minute. On the other side of the board, we can see this is the ground connection going to the battery pack, and this is the positive connection. The positive side of this is going to go through a 250 milliamp fast-acting fuse, or at least I believe that's what that component is. And then that's going to go through a Schottky diode. After that, it's going to go to the other side of the board, and you can see that via whenever we flip to the opposite side. And by the way, I have reversed this so that it lines up perfectly, but that via comes right through the other side of the board, and that's going to go down to the triac right down here. It's also going to go down to another component on the board there, and it'll go all the way around to the motor connector over here. So the positive end of that battery pack basically goes straight to the motor, which is what we would expect because the motor is going to need the maximum power that it can get. And then right over here is where our main regulator is. So this is a 5-volt regulator that has the input in the middle here. So that center pin is the input voltage that's going through to the other side of the board there. And then the output is going to be going to this fat trace right here, and that is our 5-volt connection for the rest of the components on the board. Over here on the right side, we have the connection to the motor, and that motor has a freewheeling diode hooked up across it. That's to protect all of this circuitry from whenever the motor is suddenly turned off, because it's controlled by Q4 right here. This controller is going to send current to Q4 through R11, which looks to be a 330 ohm resistor. That's going into the base of that transistor, and that's going to turn that on and allow current to flow down to ground through the motor. And the other end of that motor we saw was connected basically straight to the battery, which is through this diode D8 and the fuse right here, so that's protected through that side. One thing I find kind of interesting is that the controller here appears to be connected up to a header on the top right of the board to be programmed. So it looks like they're doing an inline programming for this. You can see that the first connection here is the power connection. It's got those fat traces the same size as the other power trace for 5 volts here. And whenever we go to the opposite side of the board, we can see that there is a track running over to that first pin from the power connection. So that's the 5-volt connection going straight there. Then there's the ground, and then there are 2 data connections. So those are narrow tracks that are running over to the microcontroller there. So I'm not sure what kind of microcontroller this is, but apparently it's being programmed through this 4-pin connection. And then that's what's going to be primarily controlling the motor over here. And it will also be communicating to the button board. So that's this pin right here goes up to the center of that, and that connector goes to the button board. It's got 5 volts, some sort of data line, and then ground. And that's how it's going to be communicating. So I'm assuming that is a bidirectional communication protocol, probably something proprietary for this company, especially considering this is a safe. They probably wanted to use something specialized for their communication protocol. You can see that this button over here is connected up to the controller through the back of the board right here. And that's just connecting up to the reset function of the micro. So whenever you press that button, you're resetting the safe's code. Otherwise, there's not really much going on this board. I'm not actually sure 100% what this circuit on the bottom left is, and I didn't feel like spending the time to try to reverse engineer this and figure it all out. It's not really that important. I just thought it might be interesting to take a look at how this board works, generally speaking. And let's go take a look at the button controller board, and that's kind of interesting too. Yep. Okay, cool. But then this was a little harder to get out, and I think I broke this a little bit last time I did it, but essentially we're gonna separate these guys out just a little bit. We'll have that guy. Okay. So now I believe once we have, it's kind of hard to do on camera, but once we have all those loosened up, we should be able to pop this guy out. Yep, there we go. And we can see exactly what this board has in it. Now, the problem mine had was that this first button had some grease inside of here, and that was causing it to not make contact. So I don't know how it got in there because I didn't see any around there. And it worked fine for years, but it suddenly started to have problems. So I just cleaned that with a little isopropyl alcohol and got that out of there. On the button board, I decided to put these right next to each other, so they are actually reversed from one another. So the connector you can see is on the left on the top and on the right on the bottom. So these are flipped over, but that's so you can read everything and see it easier. So it's starting on the, what I would call the front of the board here, where we have the keys. Now, whenever you press the buttons here, these LEDs light up. So we have D1, D2, D3, D4, and D5 that all light up. And then whenever you enter the right or wrong combination, you can have this red LED off to the side turn on. And that one is actually a downward facing LED on the other side of the board, that D6 over there. And these keys are kind of interesting if you've never seen them before. They have these interlocking fingers of metal that are not actually touching each other. And the idea here is that you're going to have a rubber button that has a conductive bottom to it. Whenever you press down on that button, it will connect these two together, usually with a little bit of resistance, but that can be detected by the microcontroller. So every time you press a key on this, it's just shorting these two together. And I did verify that you can just short these out with anything and it will be detected as a key press. On the back side of the board, we have the connector here that has ground, communication, and power coming in. So we've got our 5 volts coming in there from the regulator on the main board that we just talked about. That communication line comes in, it goes underneath this microcontroller and disappears. Now, I would guess that this company, SyncMOS, is the same company for the other microcontroller we were looking at, mostly because it looks like they're programmed exactly the same way. So if you look up and to the right here, you can see that they have the same type of programming header up here. So they have the 5 volts coming in on the left, then ground and 2 communication lines, and those work their way back to the microcontroller. I expect that these are both programmed using the same system, probably with different programs. And I would guess that there's one of 2 ways that this one is programmed. So either it's going to receive the code from the main microcontroller, and then this one is going to listen to the keys, and it's going to figure out if the code was correct or not and only send back yes or no. Or this one is going to read in just the key presses and then encode that and send it back. And then the controller is going to send data to it and tell it when to turn on and off LEDs. And realistically, I think the second one is more likely. And it's what I would do personally, because this one doesn't really need to be smart. There's no reason for it to have intelligence on it. You just have it when you press key 1, this one sends back 1 pulse back to the main controller to let it know key 1 was pressed. And since this is a safe, maybe they encoded that, used some sort of specialized coding for it, but probably not. It's probably very, very simple here. This is all inside of a enclosed area in the safe, so it's not something you can easily get to anyways. This Q1 is used to drive the LEDs on the other side, so that actually hooks up to the D1, 2, 3, 4, and 5. And then D6 is connected straight up to the microcontroller only, so that's driven by the pins of that device. All this stuff that's not populated, I don't really know what that's for. So there's a couple transistors and a Zener diode, a few resistors there. So I'm sure they had some circuitry that was either used for testing or maybe something that they used for programming it, or, you know, who knows. It's likely something that was just used temporarily, or it may be related to another module that you can have. So this particular safe does have an option for a biometric entry, so you can use a fingerprint scanner to get into the safe, but mine does not have that feature, so it's possible that this is related to that, although I don't really see any connections on this board that would send you back to that. These two big holes in the board are there for physical mounting onto the plastic that holds it in place for the key presses. So now there is one thing on this board that I think is a poor design, and that is the diodes here. So if you look at D1, D2, D3, D4, and D5, these are all directly in parallel. So you can see the top of D1 is connected straight to the top of D2, and the bottom is connected straight to the bottom of D2. And if you follow these, they're all connected like that. Now you have to go through some vias and stuff to get to all of them, but they're literally 5 diodes in parallel. And while this works in this particular case, it's generally a bad idea to do because diodes can have very minor mismatches, and that means they're going to draw different amounts of current depending on which one has slightly different voltage levels, and those can be exponential differences in current, and that can cause one diode to burn out faster, and then when one's out, then the next one burns out easily, and so on. It can cause a major failure there. So this is probably safe. I know that they're using Q1 to drive all these LEDs, so they might be using Q1 also to limit the current through all of these LEDs, although I don't think there's much of a current limiting circuit from what I saw up there. I've seen this in a few different cheap products, and I've had it fail in a couple of cheap products myself. And I've actually gone in and replaced diodes when I've had that happen and added resistors in series just by cutting a track and then soldering a resistor right in line there with each of these, because I mean all you need is a little bit of resistance in series with those to make sure they won't burn out, and to essentially separate those different current paths. But whoever did this apparently was trying to go as cheap as they could. You know, like these depopulated parts kind of say that too. That these might actually have had a use on the board, and they just decided, hey, we don't really need them all that much, we'll just take them out, it's fine. I do find it really weird though that they have this diode over here on the back of the board, but the rest on the top. I found that very strange. Like they could have just put the LED on this side of the board and then ran vias down to the other side to power it. I also find it weird that D6 is powered. There's no resistors at all in this track, so you can follow it down. It goes down here through these two holes, and then on the other side, those are these holes here. They go down to the other side there, and that's these two holes here, and that goes straight into the microcontroller. I mean, there's nothing limiting that current at all, so whatever is inside of this, maybe it does have current limiting by itself, but I doubt it. That's the kind of thing I would do on, like, you know, a school project or a home project, but on a mass-produced product, I certainly would not do that. That's something that's also likely to cause problems. But, I mean, this thing is only on for very short periods of time. Maybe they figured the cost of adding a resistor isn't worth it or something. I don't know. It feels like that's just such a minuscule difference in price, especially when they have a double-sided populated board here. I don't know. It feels very strange to me that they went with this approach. There is one other thing that kind of bothers me here is that the grounding of this board. So whenever you see the ground line come in, this black line here, it comes in and it goes down here, and then it's connected to these two ground sections. It connects up here and then down here. And you can see like the ground comes around, but it doesn't actually connect to anything up here. And I'm pretty sure that's not connected in there. And then it comes down along the edge of the board here. So it's only through that edge of the board that the ground connects. And it actually wraps all the way around the board. And if you follow it, it keeps going all the way around here, all the way around here. And the first via that it hits is here. So now I could be wrong. It may connect there. I don't think it is though, because yeah, there's no backside ground plane here. So that guy comes all the way around, it connects to that, and then it's kind of squeezing in between stuff here, but there's no good ground connection through here. And this ground connection right here, that goes into this area down here, and that's broken right there. So I mean, it feels like there's actually no good ground connection there. So I mean, we have ground right here. Let's see. So we have those 4, that guy off to the side, those 4, that guy off to the side. That connects over to here. And that one is, yep, it's that ground, that via right there. So that's connected to the ground right there. Wow. It just feels like a bad ground setup to me. So I'm not a big fan of that. They could have easily moved this track up a little bit, given it more room. They could have stitched the ground across. I don't know. There's a bunch of things they could have done to make it better, in my opinion. But not a big fan of the ground setup on this board. And I'm not going to follow it all the way through. It's not a super complicated board, though. I'm sure you could figure it out pretty easily. But speaking of the ground connection, let's go to the other board again. So some things I saw that were problematic on this board. The ground is a problem here too. So this connector here, so right next to C2, we have the ground connection to the battery box for the board. So the main ground connection of the board. And if we look at like how does that ground connection get back to our regulator over here, the 5-volt regulator? Well, there's 2 ways it can go. It can either go up this way through the top of the board, go through this via at the top because it doesn't go anywhere else over here. Go through that via. On the other side of the board, it does have a ground plane on this side, but it doesn't go off to the left here. It's going to go down, and then you can see there's this just razor thin connection for ground down here, and that connects to the bottom side of the board through that via. Goes through that via and then back over here. That's kind of the long way, but it is a relatively low impedance path. But then if you come back the other way from the ground of our regulator back this way, we can see that it comes around that. It does not go underneath because this is a single pin right here through the middle. So that's the positive wire, so that's not going to go underneath. But it's going to come around here and it's going to go through this little really tiny connection. I mean, I don't know how wide that is, but that is incredibly small for the main ground of the board, if you ask me. And then that's going to go through here, go up through that pin of that reverse polarity circuit there, and then it's going to come back around this way. So I mean, that feels like a terrible way to ground your circuit. Of course, this is all very low current, so I mean, it's still going to work. I mean, I've had this thing for years and it works fine. It's battery powered, but I mean, it wouldn't have taken much to improve this greatly. The other thing I noticed with the regulator, at least, is that the input power is connected to a capacitor. So, the input side has a capacitor for stability, but the output side does not. There's no output capacitor here. But you might say, well, there's a capacitor here. And I mean, I really don't think that's intended for the output of this regulator. I think that's intended for the bypass for the supply of this IC here, the microcontroller. And I mean, honestly, it's a really bad bypass capacitor too, because the ground pin of this is here and the supply pin is over here. And if you look at it, I mean, how do you get back to this ground pin over here? Well, let's go to the other side of the board. There's the ground connection. It goes through this ground plane here. Well, does it go to there? Yeah, so that goes to there. Well, it's actually, I stand corrected. That's actually better than the other side. So, I mean, that goes basically straight across there through the back of the board. So, and I mean, that's pretty close. So that's way better, in my opinion, than this one over here, because that one definitely does not have that connection. This doesn't make it over to the other side of the board there. So that's not going to be good. But yeah, I mean, I'm not a big fan of the grounding layout of this board. I mean, and things like this, like that that wire that runs around like that feels like that could be squeezed over a bit and just allow ground to connect through. But, you know, anyways, there's a number of things I think you could do on this board to make it significantly better. But obviously it does work. It's in a real product, something that's totally functional. So, you know, what do I know? I'm just some guy on the internet. So, if you spot anything that I missed, please post it down in the comments. Let me know. What do you think about these boards? Pretty cool. And of course, if you want to put it back together, you just follow the reverse steps.